not need it out. What you do need out is your graph paper, and we need to fold it hamburger style. You would still have a rectangular hamburger apparently.
Like this?
Yeah, the way to really get a square piece of paper, we don't want square, but if we're talking hamburger, most hamburgers are either round or square. You would actually fold corner to corner. That's how you make a square if you didn't know that. And then you rip off the bottom. Well, it's corner to okay. All right, so your paper should look like this, and we are going to do an activity that will seem very reminiscent to what you guys are about. Well, then it wouldn't be reminiscent. Very preface to. I don't know how to speak. This is going to seem very similar to science fair. So we be quiet, you powders. We are going to analyze some data, graph it, and determine, is there an association? So many of you right now are asking different questions, like does music affect animals, or does looking at scary images impact someone's, like I don't know exactly how to explain it, so I'm not going to try to. But this team or teams of people are looking at impacts to plants. And what they want to know is what different things impact the height of the plant, because often the height of the plant determines, like, its yield, its flowers, its fruit, its vegetables. So the first thing we're going to do all together is look at, does the amount of fertilizer affect the plant height? Now, gut instinct, hypothesis, don't look at the table yet. What do you think? Will fertilizer impact the plant? Do you think it'll impact it positively or negatively? Probably positively. So we, probably positive. Use too much, you're going to burn it out. So we are going to set up a graph here to graph that data that you don't need to look at yet. But what you do need to know is your maximum y value, because we're going to make height y, and the variable we're changing, the independent variable, is going to be x, so the amount of fertilizers are independent here. Our max x is 30. Our max, y is 40. Y, x. So when I went down here, and I was judging how do I use less than half of my graph paper, well, I had about 15. If I went from here up to here, I had 15 squares, but 15 to work with 40, it's a little messy. I don't really want to do that. So instead, I just said, yeah, what if I just use 10? So I went from here to here's 10, but I can have some extra, that's totally fine. So if I have 10 squares, 10 boxes, whatever you want to say, what's each box going to be worth? 4, because this goes to 40. Right, so here I chose a scale of 4, and then my x-axis needs to go to 30. So I actually did end up using 15 boxes across here, which then allows this scale to be 2. And my smart board's a little beefy.
What half of the paper should we draw?
Probably the top. If your paper's new, I would say use the top.
Which is the top, the folded part? Do you want us to unfold it or what?
Yeah, so you're using half the paper. So, like this. Cool. An example for your viewing pleasure. Now, you don't have to label every number, right? So once you establish the scale, like once I put a 2 there, I don't have to label 2, 4, 6, 8. Like, I don't have to do all of those. I'm actually going to go back and skip some of these to make it look cleaner. Now, if you choose a different scale, that's up to you. I'm actually going to do this and just go by 4s. When you're making these graphs, you want to make sure that you leave space to put your labels. And you guys are luckily going to be able to have the computer help you when you do this for science fair, but you need to label what your x-axis is talking about, what your y-axis is talking about, and what in the world your entire graph is talking about. So I'm going to walk around here in a minute, but your top of your graph paper should look identical to mine. Like, and I'm going to give you a couple minutes to get there, but we need to label everything. Oh, that's fine.
How do you we need to make
It has to go up to 40 on the y. X needs to go up to 30. So remember, x is always your horizontal, y is always our vertical.
Or independent and dependent.
16. Then plot these points.
What is the scale for the y-axis?
By 4s, but then I just didn't label all of them because it'll get really messy. So if I label all of them, that's as small as I can write. This would be 8.
Okay.
This would be 16, 24, 32. Guess I can squeeze more. So then my scale on the x-axis was technically 2,
Yeah.
but I just labeled every 4.
So each one is 4 on the y-axis?
Yeah, each box. Now really, that's one of the hardest parts of this, because once we have our scale and our axes labeled, we just plot x, y, find it, plot it. So I'm going to walk around and help if necessary, but you guys plot those points.
Stop.
So then I'm going to start plotting my points up here. But once you have your axes, don't look up here. Like, just try to plot your points on your own, and then look up here to verify. Well, I guess you have to look up here for the data. Yeah, my bad.
Yeah.
The line of best fit does not connect all the points. It is the closest average line. That should actually be a tiny bit higher. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. So then using that ruler, remember you're going to try to average out your line so it has equal points on top and bottom. And the ones touching it don't really quite count. So if I drop my line there, it's relatively 3 above, 3 below, but they're all very, very close. Right, and I'm actually probably going to go back and make that line dotted so we can see this a little bit easier. And also, you want to run it through the y-axis.
pictures or can we do it?
No, just the best that it looks for your graph. Line of best fit is eventually your calculator does the math for you and it spits out the equation for the line of best fit. Right now we're doing it manually, which is really just like using the fact that your ruler is clear, try to get as many points under the ruler as above it, you know what I mean, like in the ruler as above it, and just like draw a line. Now obviously we want it to try to match the relative behavior of the points, but sometimes what we see doesn't really have behavior, like they're just kind of all over the place. And you're like, how do I draw a line of best fit when this looks like just like a cluster, like just a group, not like a line? And we'll look at that. So who could make a scientific conclusion to the question of will fertilizer usage impact the height of the plant? Simon?
Thank you. So yeah, it does impact it, but it's not like it's not what's the word? It's not proportional. It just but the more fertilizer you use, it is likely that it's going to you're going to get a higher height.
So I think what you're trying to say is as fertilizer usage increases,
the plant height also increases.
there we go. So that is positive association. As one thing increases, the other thing increases. Your input, your variable, the thing you controlled is what you're comparing to the results that you cared about. Right? So here your variable was how much fertilizer? A little bit, a lot of it. Yeah, a lot of it. Now, realize that was fertilizer usage over the 3-week period. So the plants down here only got 4 milliliters over the total 3-week period. That's really not very much. Plants with 0 hypothetically would have only been about 6 centimeters tall.
Yeah.
Hypothetically.
So now, before I show you your data, here's what I'm looking for. And as with a lot of things, I get to decide if I need to collect this or not. If everyone's doing what they're doing and I can walk around and just do a spot check of everyone, we're good. I don't have to formally have you turn it in. But if people are like fighting against this, this is a standard that we have to get mastered. Like you will be tested on this at the end of the year, and some of you guys are still like having issues choosing scales or having issues determining which is X and which is Y. So here's the stuff we want to review really quickly before I let you go on your own. And you got like 20 minutes to do your own task, even more than that actually. When you're looking at graphing data, the vertical, the y-axis, your output is dependent on the x-axis. So while, yes, you could flip-flop the axes and you could still graph it, when we talk like scientifically, mathematically, and we look at graphs, the behavior as we go left to right on that axis, we're looking for what happens with the y. Does it go up? Does it go down? If you ever looked at the stock market, like that's money, right? The up and down is money, and the x is what? Anyone know how the stock market works? Time, right? Almost always x is time. So honestly, we could graph does time impact the plant's growth? Well, yeah, as time progresses, the plant probably grows, but at some point it might start to die. And so the x-axis is dependent. Sorry, the x-axis is independent, like time or,
Time's relative.
yeah, it can change on its own, right? Time changes on its own. It doesn't care about the plant height. Time just changes, right? It keeps passing by. Plant height can't just change on its own. It can't all of a sudden be a foot taller. It needs time to happen. Does that make sense? When you're looking at which is which, here we all have height as an output value, so all of us are going to be working with height as our y-axis. But the scale you choose is going to be based off the data you have. Okay, so when you look at your team's table, that's how you choose your scale. Henry?
You know what would be an interesting graph to learn about? A graph that is something over, let's say it's a plant's height growing over time, but factors are put in along the way represented by the line is a different color if a factor is in a place.
Like it
And-
skews off from the original line.
Yeah, yeah.
It sounds like you're making a graph like Doctor Strange
I was,
and the whole timeline thing.
actually.
No, maybe.
Do you mind if I come up to the board and demonstrate?
Right now, yes, just because I want to make sure we have time for this. If there's time at the end, let's dive down that rabbit hole. But I want to make sure you guys have ample time to do this on your own. If you have issues seeing this, send up a representative to copy it and come back to your group. So please try to remember your respective team number. You are not reusing the graph we just made. You need to make new axes because the variable, the thing we're talking about, has changed. The x-axis has changed, and your group is different than the other three groups. Does your objective make sense? Create a graph like we just did, but without my help. No, only your team number. Only your team number. Then at the end of this, your team will decide one person's graph to share with the class. Okay, so make at least one pretty one. Boy team, good luck with that. Hey, what? Prove me wrong. Prove me wrong. Yeah, you don't have to work together. That just determines which graph you're doing.
Wait, no, never mind. Independent on the bottom.
Dependent is the y-axis, independent is the x-axis.
Mine's gonna be amazing.
Like 18 to 23. 3 on the
Okay, I didn't.
bottom. Yeah, so scale 3. Oh, no, 3 on the top.
I did not.
Wait, scale 3 to the
The top
we do the summit inside?
Then you may want to, normally we do our graphs kind of rectangularly like this, because a lot of times our x-axis we want longer than the y-axis. I agree with you on the one that we just did, this, or no, I forget which one higher. I think this one went higher, so it would make sense to make it taller like this, but normally we do it wide. Also, because that's how computer screens look. Well, none of us are normal, that's why we're at Phoenix. So, whatever you decide, it's up to you, but make sure you check your data before you determine which way to turn your paper.
So like 3 is the the height of the plant.
Hey Henry, is this yours?
Yeah.
Dependent here, independent on the bottom.
Because it's just sitting on my desk and I have no idea why.
Yeah. So that's the depth of the
It's,
cedar pop.
I had to put it there real quick, but it's pulled now.
Good afternoon, Lydia Kelliker. Please come to the remote office.
Yeah, depth of the cedar pop.
Lydia Kelliker to the remote office, please.
For summer camp thing and.
So you're doing 2.
I know what Outcamp is. Do you know what Outcamp is?
Yes.
Okay. Do you want to go?
Well, my parents are making me go.
Well, that's not the question. Do you want to go?
Sort of, yes, sort of.
Well, there you go. At least there's a start.
But I'm supposed to give these people a presentation for
But me and her both went.
but I think I was supposed to do that until my school form is done
Okay. Well, keep me posted if you need anything. Don't lose those though. So make sure you've left space to label your x and y axes. I see some people making axes really close to the bottom of the paper. That's going to be hard to label what that axis is representing.
I missed mine up twice, so my graph's wonky, so I'm not doing it. We're doing mine. My X is on.
No, because you might as well move on to this one. I can't because literally you're asking me to go backwards when every single other student in the class did what they were supposed to. So did I ask to make a picture with a sun and all sorts of like
Label.
everything that you have on there? No. So my question comes in, why did time get spent on all of that and you didn't plot the points in the rest of the class? Exactly. You have to have the self-control to not have that happen. It's not the 23 other people in this class is like, I can't Team 3. So Team 3 X values go up to 6. So our X-axis probably isn't going to work here, and the Y, but why? We could just make a new graph. We might as well just make a new one down here. X would only need to go up to 6. So obviously we can use multiple boxes for every one. Does that make sense? Because we only need to span 6 down here.
Lydia
We only need to
Caliper,
go
please
6.
come to the remote
So
office.
we wouldn't
Thank
need to
you.
go 1, 2, 3. Like we could spread those out. And then our Y. Okay, so you're getting distracted here. You're going down that road. Just kind of keep on about this, not just how you're going to beat it up.
Like I
So
got
the Y, the height,
Select the X
how
and
high
Y.
does the height go?
Switch the X and the Y button.
What's the highest height of the plant? 21, 24, 27, 21, 25. Yeah. So our Y axis needs to go up to 27. Can you make that happen?
Yeah, I was
Oh, at least that's fun.
Alright, so
So, Josh, am I to guess that you probably need to get more pencils? Am I to guess that you probably need to get more pencils for your binder? Is that why you're using pens?
and then you have a different
Pens is super dangerous.
It's
Why
essentially
do you need more pencils?
I realized yesterday.
So you gentlemen are going to restock your pencils, and tomorrow if I ask you to show me pencils, you'll have them. We talked about this on Monday.
This is great, but I
Dude, that is the opposite of fun. If you think you're done, trade it with somebody on the same team and have them check yours.
I checked.
Check for labels, check the scales. So we only need to go up to an X of 6. Let's count our X boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I'm not going to move that on the first minute. Why are you stuck on it?
This one was fine.
What is that? Okay. How many Y boxes do you have? Make it happen.
So we're using mine, is what you're saying.
Oh, poor old Patrick.
What's presented to the capital council? One of which is fine.
Is it obviously going up or obviously going down? That's okay. Sorry. Yes, Hazel?
Yeah, sorry.
Can you help me what? Sadly, I am out. So I ran out. And I think Mrs. Gordon did too.
Yeah,
What do you need it for?
I'm gonna have
Oh, I don't even know if a Band-Aid is going to help that at all. I mean, it'll keep it covered up so you don't mess with it, but what you need is lotion.
with the biggest.
Here. Put some lotion.
Alright, cool. So this is all.
This is a gift for Christmas. It's just body lotion. You
I'm
can
not
go
gonna
in
argue
whatever.
anymore, Simon.
If you don't use it, you can.
Alright, so I got the.
Meet with members of your team and decide which graph you submit for approval. So which team are you?
Yeah, I feel Charlie presents us all.
Team 2. So we're looking at depth and speed of shot effectiveness. Throughout this, on the plan, as you're doing this, go to 18 meters. And then height, what's the highest height value of going 1 to 1, instead of going 2 boxes, but we could actually do 3 boxes worth 4 if we wanted to. That gets a little funky. Or we could make 1 box worth 2. Like if we need to get up to 24, we don't have enough space to do 1 to 1. So we could shoot out each 1 box worth 2, every 2 boxes worth 3. While some of our classmates are finishing deciding or finishing graphing, real quick, give me your attention up here on the board. The statement you want to be able to say is as blank gets larger, whatever your x value was, then y blank blank, like gets something. So as we look at the graph, because we're like humans and American, we're used to going left to right. So like if I go back to the first situation, when we look at the behavior change, we're thinking left to right, what happens? Well, it goes up, quote unquote. But we could also say it goes down if we're going right to left, but that's not what we do. So what we talk about is as the x value, whatever it was, gets larger than blank, whatever your y value was, whatever you used, which for us was height, gets something. Or, as some people were complaining to me, it doesn't look like there's a relationship. It doesn't look like anything is definitively happening. And that will then determine what sort of association it has. So I want your team to decide, are you positively associated, negatively associated, or have no association? Take 2 more minutes, then we'll share it. Would I have to plot that data? 3 seeds. Right, that's 6 seeds is at 21. 9 seeds is at 18. 12 is at 12. Or sorry, 12 depth. Like a depth of 12 is at 12.
That makes up most of the group. Yep, I saw that too.
15 for the x is at 6. What? Team 2, send up your tribute. Or I mean, volunteer.
Tribute. We won't forget that. Tribute. Alina, your tribute.
All right, Lou. Let me have it. Team 3, you're on deck. Team 2, somebody not Alina, explain her graph.
What?
Yeah, ha ha ha.
Why don't I have to explain it?
Can anyone right off the bat spot anything we're missing? Charlie? Our graph is missing a title. If your team, like if the graph you're about to bring up and share doesn't have a title, title it. So, Audrey, what should have been the title of this graph?
Depth of seeds and height of plant.
Yeah, so I would have, like, to try to clean up that title, I would probably say, like, planting depth versus plant height. So, as we plant the plant deeper, Audrey, right, as X gets bigger,
The plant goes smaller.
the plant's height, the plant's growth gets small. Well, that makes sense. right? Because you put the seed way deep down in there, it's got to grow all the way back up to the surface before it ever pokes out. So this makes sense. The deeper you plant it, it doesn't end up as tall. Any questions for Team 2? Team 3, send up your tribute.
That's me. But give me a second. You have to write the title.
Keep on saying tribute.
Somebody else is going to talk about it, unless you really, really want to. Which one is it? This one? Seeds in the pot?
Yep.
I'm going to zoom it.
Okay. So, I guess I'll do this.
Hey, please give your classmates the attention and respect that you would appreciate out of them.
So this is how many seeds in a pot? How the amount of seeds in a pot affects the height growth of the plant. Okay, so yeah, as you can see, the more seeds there are, it grows slightly higher.
Does it though? Because 6 seeds seems to be the lowest point here.
Yeah, it's kind of overall kind of straight. It's kind of weird.
Yeah, the association here is kind of difficult to tell.
Like some of us had straight lines, he had positive lines.
Yeah, and the problem is we can almost make like anything look right. So if I did a line right there, it'd be 3, 3, right? 3 above, 3 below. If I did a line like this, I could get 3, 3, right? 3 above, 3. So this is pretty tough to see. Is there actually association or not? It's almost like inconclusive, right? We almost just like need more data. But yeah, the issue is 1 seed in the pot and 6 seeds in the pot seem almost identical. And same with 4 seeds in the pot. Like, it's just, there's not very much to go off of here. Yeah, it is a mixed bag, quote unquote. Team 3, send up your tribute. Or Team 4, send up your tribute. Or whose graph? Just give it to me. Eric, give me your graph.
I did not take any responsibility for this.
Good, because Liam, you get to describe it.
Okay, so ignore the random sim. I was using the utensil. Life, death. Okay, so the dots, it was kind of inconclusive because they were kind of everywhere. We could have, I think there was a line that we could have drawn that was going down, but the results are kind of all like everywhere because the 9 and the 17 were like the same, so it was kind of the whatever 18. Yeah, those two are almost the same. So.
And like this point, these 3 points are all very
21,
close.
20, 20, and 22.
Yeah, very, very close. All 4 of these, honestly. So if all 4 of these are so similar, it almost seems like it's not impacting it, right? If we took out this point and we took out this point, we could almost just say we have pretty much straight across. Yeah, so that almost looks like it has no association, right? It's not going up definitively, it's not going down definitively. And Team 5.
Now I get to do more stuff.
Thank you.
Mr. Hudson, do you stand on those foam things?
Yeah, I need to get a big mat, but these I had sitting at my house, so. Because over time, it hurts to stand this long, but it's better than sitting. Sitting is the new smoking. It'll slowly kill you. Yeah, to sit all day, every day is really bad for your blood. It doesn't circulate very well. Now, we get up and go walk to lunch and all that, but like I just would rather stand. Whose graph is this? Serena says, somebody not Serena, explain it to us.
Okay, so we found that there was association because it's all going pretty good, positive line up.
Now wait, so for anyone who can't read the title because the focus keeps going back and forth, what's your title?
Does the number of hours of sunlight per day after affect the plant height, or I personally wrote, is hourly light affect plant height?
I don't know. Stop it. All right, so do we all agree that there is some pretty definitive positive association here? Yeah. Now, what if we were graphing something like, does cutting pieces off the plant impact the plant growth? Or does, I don't know, doing something bad for the plant, but we just, like, we do a little bit at first, and then as we do more, it gets like worse and worse and worse. Sometimes association isn't linear. So, pencils down, eyes up here. We saw this and we're pretty comfortable with this, right? Positive association, negative association, no real definitive association. I could argue, look, it's going up, but then there's a bunch of points over here. I could argue, look, it's going down, but then there's a bunch of points everywhere. So, yeah, right. But then all of these points are like goofed up. So sometimes association has a very definitive behavior, but it doesn't like keep that behavior necessarily over time. So negative linear association, we're used to, like, I can draw a line and pretty much equal out the points on top and bottom. But here, if I try to do that, there, that line seems to match. In the middle of the graph, this line seems to graph. In the middle of the graph, or at the end of the graph, that line seems to be the appropriate.
It's what's it called? Exponential.
It's exponential. So, when we don't decay at the same rate, or don't go down, we normally call it decay, but that creates a curve, and a lot of times it never reaches zero. Or there's some sort of asymptote, which is a big old fancy word to mean a line we can't touch. We can get close to it, but we can't touch it. Oh, the expansion of the universe? Yeah.
Yes, apparently the expansion rate of the universe will eventually go up, and just after an infinite amount of time it will stop expanding.
Well, good thing we'll never get to an infinite amount of time.
Yes.
Good thing we're all safe. All right, and then the last thing that I think we've talked about before, outliers, right? So all because a point doesn't match what we're trying to say doesn't mean we can't say what we're trying to say. What if this plant that we were like trying to keep track of, this is like the beginning, right? Especially if X is time. What if like your baby brother or sister came and like abused the plant, and all of a sudden this one doesn't match your data because something else happened? It might just be an outlier. But they don't know what a plant is. All of a sudden your plant's like, you know, kids are like cats, right? They just, you're young people. You're not like kids. All right, pack it up. Have a great day, guys.